This is Geometry, Semester 1. It's the unit on similarity, which is unit number 8. And it's the fourth lesson, AA. So that stands for Angle-Angle Similarity Postulate Practice. We'll explain that more in a moment. It is on creatormath.com. You may, under the Geometry tab, you may have to Google creatormath.weebly.com. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents, with the notes for those pages from creatormath.com. So before we go straight into the problems, let's take you to where those notes are. Because I know they can be hard to find. Here's the website address. It's creatormath.weebly.com. Please type that into Google. If you do, you should get to this home page. Looks like this. If you have any questions on the composition book, please scroll right down from this home page to the large print composition book and the picture of the composition book. Please follow all of these videos. Watch them all. Follow these deadlines and follow these directions. If you do, you should have a 90% to 100% on your composition book. And those notes you need to do these problems. Let's go to the Geometry tab where all of the notes are. There's also videos here. There's also problem sets. And of course the vocabulary. This is the Vocabulary Geometry Practice Study PDF. This document has every geometry vocabulary word we will use for the entire school year, and it is searchable. Download it to your device and then Google how do I search a PDF on whatever kind of device you're using. It's a little bit different for each device, but it is searchable. You should be getting 100% on your vocabulary practices because that document is very helpful. Now we're going to scroll to the semester and the table of contents. So for this particular video, it's semester 1. This is the geometry table of contents. You should have copied this entire table of contents for semester 1 onto pages 2 through 6 of your composition book by now. If you haven't, please stop what you're doing and do it now. By the way, there's videos back on the home page of how to number your pages and video examples of great composition books, etc. Right? Watch all those videos and you'll understand a lot more if you don't understand the composition book. So now we're going to go down to this unit in the table of contents. So here it is right here, similarity. That's the unit. You see the lessons 1, 2, 3, 4, 5. We're on lesson 4 right now, AA, Similarity Postulate. On these pages of your comp book, these notes go. Please don't look at this video for the page numbers because by the time you view this video, these page numbers might be different. So we're going to click Notes. These go on those pages. You might have to load it a couple times, fair warning. In fact, see how it remained blurry? This is not loaded all the way. See that? So I'm going to go back, do it a second time. Number 4, Notes. Try it one more time. And knock on wood, for me, it's always worked by the second time, right? See how it cleared up? Now it can be expanded and we can see what's actually written there. So if it's still blurry, it hasn't loaded all the way. So this is what you're going to copy into your composition book, the standard, the essential question, what is AA, Angle-Angle Similarity Postulate? So by now you know a lot about similarity because this is the 4th lesson. I may not go back and explain everything with that, but let's just talk about this Angle-Angle Similarity Postulate. This says that if you have two triangles and the angles are the same for both, then we can determine that these two triangles are similar. So are these triangles similar? Question mark. Why? So yes, they are by the Angle-Angle Similarity Postulate. And what we're dealing with is corresponding angles. Corresponding means the same location but on different shapes. Notice the 34 degrees and the 34 degrees. Notice the 42 and 42. So because there's two, it doesn't matter which way you flip these. You can flip one way and make them match up. 34, 42. The third angle has to be the same for both. So all the angles of this triangle correspondingly are the same to all the angles of this triangle. And that allows us to say that these two triangles are similar. Now, if the side links would happen to be all the same also, we would be able to say they are congruent. But at the very least, we can say they're similar right now. So scale factor, we don't know because there's no side links. No side links are given, right? So we don't know what the scale factor is between them, but we do know they're similar according to the Angle-Angle Similarity Postulate. So here's another example. Here's 1 tick mark, 1 tick mark, 2 and 2. That tells angle correspondingly are the same of two different shapes. Are these triangles similar? Yes, because of the Angle-Angle Similarity Postulate. So Let's see what else is in here. Copy all this in, including vocabulary. Corresponding means matching locations in two different shapes. Similar means proportional, right? We always bust out our model of the helicopter, which doesn't have any more rotor blades because they broke off over the years. It's one of the models from my classroom, right, that over the years took some beating. And fair enough, we can still see this as a scale model, which means it's proportional to the real helicopter, right? And this is a 1/48th scale Dolphin made by Aerospatial in Europe. This has been shrunk down, so we took every part of the real helicopter and shrunk it by 48, divided it by 48, reassembled it, and came up with this model, right? So that's how scale models work. If I could just get it to focus, come on. Here, okay. So that's what proportional means, or similar means in geometry. There's a couple other examples here. Copy those into your comp book. And now let's go ahead and start the practice problems for this lesson. So what does congruent mean? So in geometry, congruent means equal. And it means same shape, same size. In fact, the exact same shape and the exact same size. We say why is congruent important? Because it's multiple aspects of equality. A triangle's, say it's a triangle, you've got 1, 2, 3 angles and 1, 2, 3 sides. Is it exactly the same shape and exactly the same size as this one? Well, we need to compare multiple aspects of equality. It's not like the old days. The old days was just one aspect of equality, so we used equals. Now we have multiple aspects of equality, so we use congruent, right? So what does proportional mean? Proportional means similar in geometry. So it's a smaller or a larger shape related to each other, but so it's exact same shape, different size, related to each other by a scale factor. And scale factor works in the direction that you're going. If you're going from small to large, you're going to have a multiple. If you're going from large to small, you're going to divide everything by something, a divisible, right? Something divided by. So what is the symbol for congruence? Congruence is this one here, and equals with a squiggly over it. What a similarity symbol is a squiggly line like this. Look at the top left corner of your keyboard and you'll see an example of a similar symbol, right? And we're going through this rather quickly because it is the 4th lesson and these have been on all the prior lessons too. So we've already discussed this quite a bit if you're on the 4th lesson. Are the following shapes similar? If so, why? So this is going to run us back through prior methods, postulates of determining similarity. What we have here is a side related to a side, and please watch those videos first before doing this lesson. Don't just jump into the 4th. Start at the 1st, do the 2nd, then the 3rd, then this one, because I'm going to move a little bit quicker. I'm not going to rotate the triangle to the same orientation. I'm just going to expect you to be able to see it since you've been through it several times. So what did we multiply 5 by to get 15? This is 3x, right? That's a scale factor of 3 going from small to large. Here 12 matches up with the 36, and the included angle, which means between the two sides, is 1 tick mark. So 5 included angle 12. The included angles are the same. This would be side, angle, side, similarity, postulate. So yes, they're similar. It's the side, angle, side, similarity, postulate, and the way we write it is triangle. ABC is similar to triangle DEF, right? And I remember the prior units, they ask us these problems too. I don't know if it's necessary to ask us again, but let's do it. They want to know what they say they are similar. What's the scale factor going between the two? We just did it. It's the same problem. We went from 5 to 15 and 12 to 36. This is 3x. This is 3. Now they're going to reverse it and go from DEF to ABC. So now we're going from big to small. So this has got to be 1/3. Same problem though. So if you're going from small to large, 3 times. Large to small, 1/3, because you've got to divide by that, right? You've got to divide by a 3 to get down to the smaller size. Just like our smaller helicopter, we had to divide by 48 to get to that smaller size. Let's do another one. This 10 matches up with the 50. The 8 matches up with the 40. It looks like we're multiplying everything by 5, so 5x is the scale factor in this direction. The included angle has 2 tick marks here, 2 tick marks here, so this is side, angle, side. That's why we can say they're similar. So scale factor is 5 to the larger and 1/5 from the larger to the smaller. So now they ask, what is it going in this direction? Scale factor is 5. Then they ask, and these are the same 2 problems, that's why I'm going so quickly, and we've done this on the other one, so it's 1/5 going in this direction, large to small. Here's the next one they're going to ask us. So now this looks like a side, side, side if they're all proportional. So let's match them up. The small 5 matches up with the 20, the smallest, right? So we had to multiply this by 4x. Now let's go to the medium, 10, and the medium here is 40. Sure enough, that's 4x. And then we had to go to the 12, to the 48, the largest here, to the largest here, 4x here. So as long as they're all the same, this would be considered a side, side, side similarity postulate. Right? Now they're going to ask us, what is the scale factor to the large, 4x, and what's the scale factor from the large to the small, 1/4. So I already know the answer to the next 2 problems. There it is there. In this direction, we went 4x. And in the reverse direction, if we went 4x one way, now we're going DEF to ABC. Now we're going large to small. We have to go 1/4. And again, I went slower on these and explained a little bit more on prior lessons. They're repeating these problems for us. That's why we're moving so quickly. Are the following shapes similar? All right, let's see what we got here. So this looks like it's going to be side, side, side if the scale factor is consistent for all of them. So let's take the smallest side, 5, and the smallest, 30, and match those, small to small. Then we'll go medium to medium and large to large, okay? How many times do we have to multiply? This is 6x. Right? We had to multiply 5 by 6 to get 30. Medium is 8, and medium here's 48. Is it consistent? If we multiply 6 times 8, do we get 48? Check, it's still 6x. And then we're going large, 10 to large 10. Did we multiply 10 by 6 to get 60? Check. So this is going to be side, 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 SSS, similarity postulate, triangle ABC is similar or proportional to triangle DEF. And proportional would mean that one of them is a scale model of the other. This is a repeat of that same problem. They want to know what's the scale factor going from small to large. It's 6 because we multiplied each side by 6. And what's the scale factor if we go from large to small? Here. So here it's 1/6. Divide by 6, right? Multiply to go bigger, divide to go smaller. And I think most students, that's pretty reasonable of an idea for them to grasp. Are the following shapes similar? Why? So now this is interesting. Now this gets into this lesson's similarity postulate, which is angle, angle, right? So let's consider this. We have an angle here with 1 tick mark and an angle here with 1 tick mark. They match. And then the angle next to it is 2 tick marks. So yes, we can say these 2 triangles are similar or proportional because of the AA, angle-angle similarity postulate. And what it basically means is the third angle's got to be the same because we would take 180, subtract these 2 for both, and they're the same in both, so this one's going to be ending up. And if all the angles of a triangle are corresponding angles of 2 triangles are the same, then those 2 triangles at the very least must be proportional or similar. And if we did have more information that all the sides were the same lengths correspondingly, the corresponding sides were the same lengths, then they would also be congruent. They would also be exactly the same. We don't have that information, so we just stick with similar for the moment. All right, given the following 2 shapes, given that, it is given that the following 2 shapes are similar. What is the scale factor from one to the other? So this is the one we just did with angle, angle, and per all the discussion I just went through, we really don't have any idea what the scale factor is. In fact, it could be 1. They could be congruent to each other. So we're going to go with there's not enough information to tell what the scale factor is. And now if they ask us the reverse, going in this direction, we don't know what the scale factor is. Going in this direction, we do not know what the scale factor is. So there's not enough information to tell scale factors from what we've been given for this type of problem. Okay, are the 2 shapes similar and why? So here we have, looks like 2, 2, 3, and 3. So fine. We're going to go with angle, angle similarity postulate. And if they dare ask us what the scale factor is between the 2, we're not going to have enough information. Let's see if they do. Ah, I see where they're going with this. Yep, they're asking what's the scale factor going this way? We don't know. Not enough information to tell. And what's the scale factor going in the reverse direction? We don't know. Going this direction, we have no idea. There's just not enough information to tell. Okay, so that's the angle-angle similarity postulate. And we're now going to just make sure that you match up the video lesson of this title with the actual problem set you're doing so you can match them up, right? Geometry Semester 1, it is the unit on similarity, the 8th unit, and it's the 4th lesson, Angle-Angle Similarity Postulate Practice on CreatorMath.com under the Geometry tab. Hope that helps.